Hello friends, let us solve one numerical problem involving sampling, quantization and time division multiplexing. The problem statement is as follows. A signal m of t band limited to 3 kHz is sampled at a rate 33 integer 1 by 3% higher than the Nyquist rate. The maximum acceptable error in the sample amplitude, that is the maximum quantization error, is 0.5% of the peak amplitude MP. The quantized samples are binary coded. Find the minimum bandwidth of a channel required to transmit the encoded binary signal. If 24 such signals are time division multiplexed, determine the minimum transmission bandwidth required to transmit the multiplexed signal. Use the fact that a noiseless channel of bandwidth 1 Hz can transmit a maximum of 2 independent pieces of information per second without error. Let us solve this problem. What is given in the problem is a signal m of t band limited to 3 kHz. That is the maximum frequency of the signal is 3 kHz. So W maximum signal frequency, W is equal to 3 kHz or 3000 Hz. Next, the sampling rate is given to be 33 integer 1 by 3% higher than the Nyquist rate. Okay, so the sampling rate Fs equal to 33 integer 1 by 3% of the Nyquist rate. The Nyquist rate is 2 times W. So this much higher than the Nyquist rate, so plus 2 times W. So this is the sampling rate. Substituting the value of W here, we get 33 integer 1 by 3 is 100 by 3 into this becomes 1 by 100 into 2 times W, W is 3000 plus 2 times 3000, and this is equal to this 100 and 100 cancel. 3 cancels 3000 1000 times, so 1000 into 2 2000, so 2000 plus 2 into 3000 6000 equal to 8000 samples per second. So this is the sampling rate. Next, the maximum acceptable error in the sample amplitude, that is the maximum quantization error, is 0.5% of the peak amplitude MP. Now we know that the maximum quantization error in a PCM system is equal to delta by 2. We know that the quantization error is uniformly distributed in the interval minus delta by 2 to plus delta by 2, and that is given to be equal to 0.5% of the peak amplitude MP. So 0.5% of the peak amplitude MP. So from here, delta, the step size, comes out to be 2 into 0.5 is 1, so MP by 100. Now we further note that the number of quantization levels L is equal to the dynamic range 2 times MP divided by delta. So it is equal to 2 MP upon delta is MP by 100. So it is equal to 200. The quantization levels are 200. Now the number of bits required per sample N, so L is quantization levels, and bits needed to encode the quantized levels, N equal to log of L to the base 2, that is equal to log of 200 to the base 2, and this comes out to be 7.64. And now the number of bits must be an integer, so we take the ceiling of it, that is ceiling of 7.64 equal to 8 bits per sample. So each sample is encoded using 8 bits. So what next is asked here is find the minimum bandwidth of a channel required to transmit the encoded binary signal. Now for that we need to first compute the data transmission rate. So the data transmission rate or the bit rate, data transmission rate, they were denoted by TR, transmission rate, maybe TR equal to NFS. N is the number of bits per sample and Fs is the samples per second, sampling rate. So N is 8 bits per sample times 8,000, the sampling rate, 8,000 samples per second, and what we get is the data rate in bits per second. So 64,000 bits per second or 64 kilobits per second. So this is the data rate. And now use the fact given as a hint here in the problem. It's a very important result in communication that a channel of bandwidth 1 Hertz can transmit a maximum of 2 independent pieces of information per second without error. Here we take 1 bit as 1 piece of information, and therefore 1 Hertz can support 2 bits per second without error, and therefore the channel bandwidth required to support this data transmission rate is equal to half of it, that is half NFS, that is 1 by 2 times 64 kbps, kilobits per second, and the result is in Hertz. So it is 32 kilohertz. So this is the channel bandwidth required for transmitting the signal at the data rate 64 kilobits per second. Now, the next thing asked in the problem is that if 24 such signals are time division multiplexed, determine the minimum transmission bandwidth required to transmit the multiplexed signal. You have seen in the previous lecture that the channel bandwidth required for a TDM system is equal to n times the bandwidth required for one signal, assuming all signals are band limited to the same maximum frequency, and accordingly for TDM of 24 such signals, the bandwidth required will be 24 times the bandwidth required for one signal, and that is 24 into 32 kilohertz, which is equal to 768 kilohertz or 0.768 megahertz. So that's all for this lecture. I hope this problem, which involves sampling, quantization as well as time division multiplexing, is clear to you. Thank you.